Hey, Adrian. Alright, man, so bear with me. I've got limited brain cells right now with the baby and all that stuff. That I'm sure that these thoughts that I've given you are kind of scrambled. Maybe not, but anyways, what I just decided to do was make a Word document here and just kind of give you some thoughts about what you should be doing. I'm editing as I'm looking at it. I didn't look back and edit. I just kind of wrote because, like I said, limited time. But anyways, if this doesn't make sense to you, please let me know. So anyways, go through this document. I just kind of wrote down some ideas that should get you through the next few days. Again, this is my routine, so I apologize if I kind of glossed over things. Let me know if whatever I can do to help you out. Okay. So anyways, if we just kind of go through this real quick, Integrated Math 1, Monday, what you're going to do with the kids, they have, actually no, they shouldn't have an assignment from Thursday and Friday when I was gone last week, but they did do some work, so just remind them that those that got it in on Friday got an easy 10 points. So if there's students that were there on Friday, Thursday, and Friday, and they didn't hand their stuff in, it's too late. And if there's students that were really gone Thursday and Friday, and I don't know how you would know for sure, just take their word for it, I guess. Tell them to wait, and I will update my website, and I will show you how to access my assignments on my website, so students can, if they want the easy 10 points, they can go on my website, print it off, and get it in. Okay, so anyways, just tell them that and tell them to be patient. But the kids that did get it in, I will get them their 10 points sometime this week. So just let them know that. Okay, so get familiar with the students. Let them know who you are. At the beginning of class, tell them a story, kind of ease the tension a little bit, and then start doing some math. So what I would do is just let them know that they were playing a game called What's in My Bag that has to do with expressions and input-output tables. So find some input-output tables or just make some. You can even just take an expression, like say, what if we were working with 4x minus 5, and then create an input-output table to start looking at patterns of the outputs. So that, or if you find some just input-output, have them write the expression that describes the number pattern. Okay? So if you show them those kind of examples, we're leading into building equations. Looking at an equation, for example, like on this document I gave you, 2x minus 4 equals 2, letting them understand the idea behind solving for x, which means given a certain output, like in this case 2, to the number pattern 2x minus 4, what number did they have to put in to get out of 2? So if they can look at an equation like 2x minus 4 as a number pattern saying that all you're going to do to each input is double it and then subtract 4, which input would, when you double it and subtract 4, gives you a value of 2? And make a table and just try randomly select input values that aren't going to work, and let the students see through multiple examples how the number pattern is really affecting your input. It's just doubling, subtracting by 4, and then build to the idea of why it really is 3, why x is 3. Because when you double 3, you get 6, you subtract 4 from it, we get 2. Okay, so do multiple examples with that, and I would have students just do the examples in their notes. Okay, so make the tables with the smart software, use the smart board, and show everything, and have students just work along in their notes. You're going to have students who aren't going to take notes. Other than putting more work on myself and being a slave driver, I don't know how to motivate all students yet to take notes, but they kind of know what they're getting themselves into if they don't, I guess. So anyways, that kind of leads you into Tuesday, where then we can get the algebra tiles out and we can start connecting to those number patterns by representing our equations using one-step and two-step equations as our examples and representing them with algebra tiles. Make sure that sheet of paper that I drew the black line on that we're going to use for equations, make sure you make copies for every student. If you don't have one, just make another one, and then you can even write work mat on it when you make a copy. Algebra tile work mat might be pretty good. So anyways, hand that out to the students. Let each student get a bag of algebra tiles, and then you could use the document camera. It has a little image mate icon here. I'm at home, so I don't have mine connected, but if you have that, click that button and hit the light on the document camera, the Elmo, so that it's blue, and you'll see it pop up on the screen. So work with the students through 1 and 2 step equations, come up with those on your own, or get some from a PDF. You can write on the Word documents and PDFs with the smartboard, and also you can write on your document camera image with the smartboard. So enjoy the technology. It's a blast. Students like it, and they really do learn from it. For their assignment on Tuesday, there's no assignment on Monday. For their assignment on Tuesday, I would either go to CUDA software or just find some assignment that has like 10 problems or less, somewhere around 10, and have them work through the assignment by drawing the algebra tiles, and as they add numbers to create 0 pairs, and adding x or variable tiles to create 0 pairs. Have them draw that, show that we have the 0 pair happening, and that their solution is shown as a picture. They need to understand the math through the tiles, which really then allows them to draw the picture. So that'll be their assignment. Just go find a 1-2 step solving assignment. There's a million out there. Find one or get one down, whittle down to 10 problems. Have them use a separate sheet of paper and show their pictures, and that'll be their work for Tuesday. Then what I would do on Wednesday, since you're using an assignment that's around 10 questions, just take the whole period Wednesday to correct the assignment, but going over each problem. Either you showing them with the algebra tiles with the document camera and the smartboard, or let a student do it. Just ask them, hey, who thinks they did this correct, and if they want to share. And there are some students that do like to share, so let the students do the discussion. You're just there to kind of monitor and ref and walk around and make sure the kids are engaged. Okay? Technology is a problem. I personally just say, hey man, put it away, and usually they do for me. I haven't had an issue with technology. I guess, like Ashley said, maybe I'm a little loose on it, but it's the battles that you want to pick, and I choose to just kind of remind them to be respectful, and it seems to work well. Okay, so when you correct the assignment, what I would do is make sure that the students have a different colored pen or marker as they correct, and make it simple. Correcting for me is not hard. I don't put a whole lot of energy into it. I want to get a grade, and the kids, on the most part, are honest, so they will correct accordingly. There's some kids that probably didn't get it in, and they're needing the extra points, and as far as I'm concerned, good for them for getting one in, I guess, if they decide to copy or cheat or do something. But again, since I don't focus on it, I know that during the test they're not going to do well because they're not learning. They're just getting assignments done. If you do catch it, I'm not condoning by any means, but if you catch it, tell them that that's not good. Okay? Alright, so that should get you through Wednesday in integrated math. Core geometry. There's a PDF I found online called Transformation Properties. It's attached in the email. There's 3 sections of pages that I want you to copy. 19 through 21 we'll use on Monday, and 24, 26 we'll compile with those to be their working review in class. And it's over, here's the PDF by the way. I'm already on page 19 when you pull this up. It looks like this. It's isomic transformations, which is our reflections, rotations, translations, and there's some good problems on here. So problem 1 on page 19 is describing a transformation here, like a translation. They need to show a vector. They need to show, let's see if I have a tool to draw with here, an arrow. I don't have one. Sorry. A vector, though, to show the transformation, they can describe it by saying what it does, and also vector notation. Okay, same deal here. This is a translation, rotation, rotation, and then we got a reflection and a reflection and a reflection. So students can get a little review on visualizing the orientation of each transformation, because that's huge when we start moving figures around a plane. We have to know what a rotation does to an object as far as orientation versus reflection and translation. So the students need to work on this. This part is half of their assignment. So you can, and I would on Monday work with the kids. You can even just pull up this PDF on the smartboard, and like I said, you can draw on it, and have the students come up and draw the line of reflections or the point of or the center of rotation, and describing the rotation as far as how far it went, and then translations with vectors and vector notation. Let them do it. There's some nice teacher notes here if you want to read these and kind of think about what the problems say. All right. Okay, so now, where are we at? Oh, so the next section is going to be their homework on Monday. So page 28, through 29. This is a work with a partner. I saw on this and I like it. It says draw a geometric figure on the grid, label the figure, and then they're gonna write. So they're gonna draw like a triangle or something on this coordinate grid. Tell them to draw a triangle, or just leave it at a triangle, I guess. And they need to write a sequence of 3 transformations and show their work. Like if they're going to reflect it, have them just draw a random line, have them reflect over it, rotate, translate. They need to do 3 transformations, and then on Tuesday they're going to have another student figure out what they did. So they're going to draw it on this first sheet right here. Okay, so this first, oh dang it. Let me get back to that page. They're going to draw their figure. They're going to draw any line that they reflect over. They're going to draw the point that they rotate around. They can use compasses. They can use rulers. They can use any tool that are on the shelf in my room to show you that they know what they're talking about. They need to show the properties of our transformations, and so that this is their work. On the second one on page 29, it's going to be their cleaned up picture to show their pre-image, the one they originally drew, and the image, the one that they finish with after their 3 transformations. They're going to draw both of those. Make sure that they use the labels, our prime labeling. Make sure that they do that so that the other student knows which one's the pre-image and image, and also corresponding points. Then the other student needs to figure out how to get from their pre-image to the other student's image. So use the class, use your judgment to see how long that should take. I would imagine that would only take, once the student hands it over and they work, I would give them maybe 10 minutes. Okay? And what that's going to do is that's going to lead into a GeoGebra conversation that we're going to have. This one, what I would do, Adrian, too, with our properties of transformations, of reflections, rotations, translations, is go online and get some research. I Google properties of each one, and then just look at the geometry behind it. I took some notes. I wrote some notes a long time ago when I was doing my MEA presentation. And so what I just did was I took a picture of it, and I'll just go over kind of the highlights with you. When we do reflections, like if you take this point and we reflect over this line, the distance that it is from the line of reflection is equal to the distance of the pre-image, or the image, right? These segments are the same. Basically, the segment gets bisected by the line of reflection if we connect a pre-image and an image point. This is the geometry that's within reflections that we've talked about in class, isosceles triangles, because any point on the line of reflection is equidistant to the pre-image and image points, right? So we have an isosceles triangle here. So when you bisect the base of an isosceles triangle perpendicularly, it goes through the vertex point, and you can see some congruence here. But that's basically reflections. So I've also got an app here called Reflections with Bugs that I'll put in your email as well. And this, if you want to refresh with the kids too about properties, then use this reflection with bugs. And these little hide show toggle buttons here can show you and lead you through the conversation of reflections. When you pull it up, this is what it looks like. You have Bugs Bunny, you got a line of reflection, and I put key points on bugs because I talk about an image or any polygon being an infinite set of points, but we only look at the key points, like the vertices of a polygon, or I made some here on bugs. So we're going to reflect them, talk about what they notice and what they recall from reflections being equidistant and perpendicular, right? Those are the main properties that we need to talk about. The line of reflection is the perpendicular bisector of the segment that connects pre-image and image points, right? So then I show that by connecting those pre-image and image points with the segments, and they can talk about the congruence, bisecting part, and then also showing the 90 degrees, okay? And then I put a point on here. So as you click through these, you can see what happens. Play along with this and check it out before you use it, please. But you can see all these isosceles triangles here being formed, and that red dot is just any point that's on the perpendicular bisector is equidistant to the endpoints of these segments. Okay, those are the properties of reflections that we've talked about. So mess around with that app; it's pretty cool. And you can also use the transformation tool to reflect bugs. So to do that, all you have to do is make sure that bugs is the only thing selected, and you can see a gray, highlight thing around it. Go to your transformation toolbox. It's this one here, and reflect is already the first option. So just click that tool, and if this is highlighted, anything you want to reflect, you just highlight in GeoGebra. Then you click on your line of reflection, and it goes ahead and reflects. Then we can use our point tool, and we can move the line of reflection around, and we can show lots of examples of these properties to refresh the kids on reflections and also orientation. So enjoy that app, use it in a lesson to refresh the kids on reflections. Okay, the next thing that we're going to talk about is rotations, which rotations here, if you can see this, I have another app I'll show you here. It relates circles, circles and radii being points on a circle are equidistant. Okay, it reinforces everything from reflections. We have isosceles triangles happening here. Okay, so with rotations, what I talk about is when we rotate an object around a point. Okay, say like this point, and I rotate around it. Every point on the on the path of rotation, every single point, which in relationship to the pre-image has an angle formed at the center of rotation, right? But any point is equidistant to the center point. So the distance that a point is from the center of rotation is equal all the way around the path, which is a circle, and that's where circles come from. So another GeoGebra app that I have for you is called, and I need to find it real quick, Rotation Properties with Leonardo. Okay, so I got Leonardo here from Ninja Turtles. This slider over here changes the angle of rotation. So as you move it, you can see the rotation happen around point A. That's the center of rotation. Now each point, notice I have a lot of toggle buttons here. What I did with this one is, because this gets pretty busy if you show everything, I also broke down individual, based off of F and F prime here, triangles getting formed. And you'll see what I mean as we go through these. But this angle changes the angle of rotation. In GeoGebra, you can right-click a slider, and you can go to Animation On, and you can see this thing animate. Right? We got a little pause button down here. We can just pause it whenever we want to. But this is nice as you explain, and you see lots of things happening. And you want to go to the next thing, just pause. So now to show an angle of rotation, to show the actual rotation here, you can see this angle. It matches what this angle is. Okay, so as we repeat the animation, you can see that angle of rotation to help these kids review. Talk orientation. Also, you can move the center point A around, which moves your rotation point or object around as well. Okay. Then I showed all angles. So this is where it starts to get kind of busy, but it's cool. It's color coordinated, and they can see all these angles are the same. So as we animate, those angles are all the same. Orientation of the angles are a little different, but still the same angle measure. Okay. So you may want to hide this too as you talk, and then show a path of a rotated point, which is a circle. So if I had this on, notice the circle is there, but if I show, or if I uncheck show all angles formed, I can just look at one specific circle. So again, as we animate, you can see the path of rotation of an object, of a point, and then if you click on all, show all rotated paths, you can see concentric circles, kind of neat looking. Okay, and then if we are done talking about that, we can just not show that. We can show an isosceles triangle formed, or we could show all of them. Oops, I need to have all angles formed as well. That'll show all the isosceles triangles. You can see all the paths that they follow. Okay, so this can be a good review. Let the kids kind of stare at it as you stare at it. It's kind of neat looking. Perpendicular bisectors, how to find the center of rotation. Okay, this is a big math question here. So I'm going to hide everything real quick. And I'll show you how to find the center of rotation. A theorem that we have in GeoGebra, and it's based off of our properties of rotations, basically. Since a point, let me see here. Since a point that's getting rotated, and it's a pre-image point and its image point that's getting rotated fit on a circle, then we have radii, right? That's what this angle is all about. We have two, oops, not that one. We have radii formed, so these segments are the same. So if I connect the pre-image and the image point of any corresponding set, we get an isosceles triangle formed, right? And if we bisect that perpendicularly, that point's going to go through, or that line, that perpendicular bisector is going to go through the center point, okay, like this, right? And you can use GeoGebra here with the constructions to make that if you want to, but you don't need to with this app. So then that's kind of how we can talk about, remember that any point on the perpendicular bisector of a segment is equidistant to the endpoints. And that's really saying that these radii here are equal, so their distance is the same from A. So then if we perpendicularly bisect two sets, so on this app I have lots of them, but if we can imagine two sets, and I should have done that, if I make two perpendicular bisectors of two different segments connecting pre-image and image points, we'll find the center of rotation. So sorry that didn't come out very good, but you can kind of see that happening with the app. Okay, so play along with this one too. Use this in your discussion again to review, and just treat it like rotations might be new, and have the students come up with what they've learned. Okay, so anyways, you can use that, and that'll help them with understanding their assignment that they have to do by hand. Okay, if by Monday that you use these apps in your discussion and you're not ready for them to do a homework assignment where they're making their own combination of transformations that moves a figure for another student, then just do that on Tuesday. Have them make it and then switch it after, like say 20 minutes or something, and let that be your period. Okay? And then we'll talk more about continuing concepts of that. Translations are easy. They're just slides, right? From left to right, up and down. They create right triangles. Okay, we use Pythagorean's theorem as we did translation. So this is what I mean, like to move this point to this point, we have to translate vertically and then horizontally. So we talked about all these things here. So yeah, I think that translations are pretty much self-explanatory. The kids get it. Okay, so anyways, that'll be kind of Monday, Tuesday. Use those GeoGebra apps, play around with them, let them just be a lesson. Hand out the assignment pages 19 through 21, 24 through 26, and have them work with that as well. So as you are talking about the properties using the apps, refer back to that PDF, just keep pulling it up and drawing on it on your smartboard, and go through the assignment talking about concept building and review. Okay, I hope that makes sense. If it doesn't, again, please let me know and I can help you out. Okay, and the last thing that I want to talk about is Math Essentials. There's this sheet here that we kind of discussed when we talked in the classroom. This is their objectives. I just took that picture and so I can talk about it here. There's two sets of, these are each exercises that you're going to print for the student. So two sets that are in the same color. Once they do both sets, then they do a diagnostic diagnostics test over these objectives. Then they do an exercise on these two, okay, that we print separately. If they pass with 75% or higher, that's how they move from exercises. They have to get a 75% or higher, so when they scan, it'll print out their percent. You just have to check on it, give them points on their weekly grade sheet that are hanging on the wall. Just put a date on it, and then I write the objective number on the line, and then give them the points. So if they got like a 75%, they get a 7.5 for points. I make their percentage out of 10, just convert it. If they get 100%, they get 10, and so forth. Okay, so then what you do to access accelerated math, you have a Renaissance learning, icon here. Just click that. If you're using the Firefox, it should remember my password. I wrote it down for you if it doesn't, but it should, just like mine does. So you're going to log in. Okay, I'm just going to talk through a couple of things here for you. I wrote a little bit about the 3 ways that students can get points in class: exercises, diagnostic tests. So once you get into the Renaissance place, you want to click on Accelerated Math Live and go to their assignment book. Okay, so in their assignment book here, there's a list of all my students in the class. Right now, most of these students, if they have a date on exercise, that means they have one printed. They either have it out, they should have it. A lot of times they'll say, I don't know where it went, and they really don't care. Just print out another one and give it to them and make them work. I try to make them responsible through a little bit here and there, but it's a challenge for sure. So let me show you some stuff. Now these ones here, like Jordan Jack and Bailey Thomas, they have diagnostic tests out, right, that they're working on. So they need to get that done. They'll just scan it on their card, with their card, and then give you their grade. You fill out the grade sheet with their percentage, and then you print the next thing that they need. If they didn't pass the exercise, they got less than a 75%, then you just go back and reprint what they did. Let's take a look at like Haley here, for instance. I'm going to grab this student here. When you click on their name in their address book, or not address book, their assignment book, you can see what they have out, which is called outstanding assignments. So this girl doesn't have anything, that's why I picked her. And you can see what they've done, recent assignments. So she's only done 2 things since I've gone to this method, which has only been a week, I believe. So she hasn't been doing much. She passed 3 and 4. She got 100% on it, so I gave her 10 points. So then I went and printed her the next exercise, which was 5 and 6. So if you look at the sheet, whoops, we don't need that. But if you look at the sheet, 3 and 4, the next one's 5 and 6. So I went ahead and printed that to her, and I'll show you how I do that. And she did it, scanned it, got an 83. So it's higher than 75. So she passed 3, 4, 5, 6 in purple here. So now she's ready for a diagnostics test. Okay, so then what I do is I just return to assignment book. I go click on her name again. So Haley Tolson. Now I'm going to generate a diagnostic. That's the test. Okay. So now that I have that, what we have here is a list of the objectives here, and you can see what they are. You can do groups of 20, so you can jump. These are all the ones that are possible for them to do, and I just go through and see which ones I like these ones, and I assign it to the students. You shouldn't have to do that. I don't know if that list is long enough. Just follow the lists that are on this page here. Get up to here, and if we need more, I can help you with that. Okay, but just work through this process to work. The students work their way down. They don't get a whole lot done, but some might start moving to get some points. So, anyways, let's go ahead and print the diagnostics. So all you're going to do is you're going to click the 3 objectives, 3, 4, 5, and 6, right? Those are the ones that we're working on here. So you click on 3, 4, 5, 6, hit generate, and it'll print out the paper for you, the assignment for you. Okay, so go ahead and if you're watching this podcast, pause it, stop it, do whatever, and see if you can get, or when you get to class or whatever, see if you can print Haley's diagnostic. With diagnostic tests, they are twice the size of exercise, so when they get a percentage with diagnostic tests, I double their grade. So I hope you heard that. I hope you understand that. I double their grade. So if they got like an 83% on their diagnostics, they got 8.3 points, so I double it, give them 16.6 because it's longer and it motivates them to work. Kind of easy points again. Okay, so that's how we do a diagnostics test. All right, so they have two cards. They have an exercise diagnostic card. They know how to handle that. Let's look at another student that doesn't have anything and see if we can do an exercise. So looking at Megan here, here we go. She just did exercise 9 and 10, or those objectives, which are right here. So it's her last one of this set before she does the diagnostics, 9 and 10. But if you look at her percentage, she got a 58, so she needs to retake it. So I gave her 5.8 points on her grade sheet, and then I go back to return to assignment book. We're going to redo 9 and 10 for this girl. So for Megan, we click on her name. We go to generate exercise, and it should be on the page where these triangles, the yellow means that they pass it, green means they didn't, check means that they did the diagnostics and they passed. So she did a diagnostics and did well on it. She's working on these 4 objectives. That's the 4 objectives in this color, 7 through 10. So now she needs to redo 9 and 10, so just click these two, generate. Okay, so the students will, you just give them, go ahead and make Megan's as well, but just go through and look to see. They might come and say, I don't have anything, and if you look at the assignment book, you can see that they have something out. So let's say like Jack here, this kid doesn't do anything. He has something out, and he say he lost it or something. So you just click on his name in outstanding assignments. You can see the exercise, and then just go to regenerate and do same problems as the original, or you can make them different. It doesn't matter. And then just regenerate, and it reprints their assignment for them. Okay? So exercises, diagnostic tests, grade sheet, and then just collect that grade sheet on Friday and just tell them that they have to get 200 points, 20 points a day. And hopefully you can figure that out. It's 7th period goes fast because you're busy, you're helping students, and you're printing, and you're doing all sorts of stuff. So it should go good for you, hopefully. Just understand the class is about motivation. Okay, well, I talked for 31 minutes apparently, so I hope that helps, Adrian, and if it doesn't, please let me know, and we'll keep working, man. Alright, thank you for covering for me. Good luck, enjoy. It's a good rush, man, if you let it be. Working with kids is crazy if you want to teach concept. So keep that in mind as you're working and enjoy it. Thanks, man. Bye.